So, folks, how many of you are familiar with eBPF here? Okay, wonderful, wonderful. About half of you. That's great. Well, before we get to that, let me say a few words about myself to manage your expectations. So, I'm a performance geek who turned to be CEO. So now I had to work more, I would guess, on the company performance than a system performance. But you know what? I still keep my passion, and that's why I go and talk on the a lot of technical conference still. In this presentation, we'll look into eBPF overview and how it works on Linux, as well as look at the practical examples of eBPF-based tools, which I hope you find helpful and be able to apply in your environments. So eBPF history and its support in Linux. eBPF, it stands for Extended Berkeley Packet Filter, right? Which is a weird name for a tool we want to use for monitoring, isn't it? Well, and reality is that is originated from the Berkeley packet filter, which was exactly designed for efficient, to build an efficient virtual machine for packet filter, right? And then extended E, right? That means it was pretty much extended to be able to be more stuff, right? So Linux kernel has support for that virtual machine called eBPF. In general, eBPF is event processing framework, which is used a lot for monitoring, but that also can be used for some other stuff indeed in the network stack. In modern versions, we have the JIT compiler, right, which compiles those programs for higher efficiency. eBPF in Linux was appeared first in 2014, right? So it has been out there for quite a while, but it is still being very actively improved. And in recent years, it's also been integrated in the PRF tooling, right? Which is this wonderful framework for interactive performance analysis in Linux. If you look at the improvements in recent kernels, you can see the list of changes enlarged, and pretty much every major, minor kernel release, right, does include some additional features in eBPF, which can range from the new instrumentation points to the various new, types, right? What kind of data structures we can use, how we can process and aggregate those events. So, as I mentioned, what eBPF is this kind of a special bytecode, like a small programs, which you can go ahead and insert in the kernel, and which would be executed when different events are being triggered. What is great about the eBPF is what there is a checks done before those programs are included. So it's not impossible, but it is hard to screw yourself up, right? So it is hard to write an eBPF program, right, to do basic mistake, then you boom, try to insert it in the trace point, and your system completely crashes, right? For example, if you just put like a tight loop in eBPF program, it wouldn't be would not pass a validation, and would not be wouldn't include. Right now, even for the eBPF itself is based on a bytecode. The LLVM CLang can compile the programs into that in the eBPF bytecode, and that is what typically used for as a part of an eBPF platform. Now, what is interesting in this case is what that compilation is tend to be kernel dependent, right? And that is why you the installation of eBPF is a little bit more involved, right? In a lot of cases. But for the good stuff with LLVM is that means few of us would actually need to run eBPF programs directly. Here is, if you're curious, eBPF code example, which actually comes from a TCP dump, which is another tool which uses eBPF, right, for for packet filtering, and it has a neat tool where you can actually dump the eBPF programs in what looks like the assembly-like code, right, for the bytecode it represents. Okay. eBPF has support both on the kernel side and on the user side. And in this case, I have an image from a wonderful, wonderful resource of Gregg. If you are interested in eBPF on Linux and using that and tools, Gregg website has absolutely fantastic, fantastic resource. But that, I think, is a very nice, nice illustrations out there. What we can see is one way or another, we will have a user program to generate bytecode, which will be verified by the kernel, right? Through BPF, it can connect to the different interfaces in kernels, right? From kprobe, uprobe, tracepoint, perf events. And then what the map is what that kind of data structure which can be used to accumulate the performance statistics, right? That probe will run, accumulate data in this case, and then we can use, again, in the user space, some program to read that data in the map, in this, display that, as you will actually see in the tools I'll show you. This is now a wonderful image, which shows you all kind of different tools which can be used to troubleshoot or analyze different Linux kernel subsystems. And you can see that the eBPF ecosystem is large, and there are already many tools which use eBPF, so you don't have to write your own probes, right? Here is another wonderful image from the same source, which really shows us in a different illustration what Linux kernel versions support, what kind of eBPF features. And I'm not spending a lot of time on that because I think these things are self-explanatory and you can research them later on the slides. Here is also from the Gregg, the interesting a picture which shows the different tools, right? It shows by how easy it is to use, right, to how mature it is. You can see that there have been a lot of tools like raw BPF, for example, was pretty mature, but that's very brutal to use. And that's nice to use what we have in the tools in this kind of corner, which become both easy to use, powerful, and mature, right? So eBPF, I think, is now at a very great time in Linux kernel that is very powerful, but at the same time very mature to use. Okay. Now, one thing I see from looking at eBPF tools is not all of them are available in the single package. The first two packages which you may want to look at would be perf tools unstable, right? Well, in unstable version there are more stuff, right, for you to use. And then there is also this IOVisor project, which has tools like BCC and PLI, which can be used for a lot of other kind of simple shell scripts and otherwise to provide those. So these are both pretty mature tools. You can get them to installed relatively easily, right? In this case, that's just example. You have a repository which has a packages which makes it relatively not too painful. Now, I mentioned already, right, what eBPF depends on the kernel. That is why you can see it has to pull in the kernel headers, right, to understand exactly data structures you're working in, what exactly different offsets for different data, and so on and so forth. Okay, let's now look at some tools in action which are based on eBPF. The first one is Profiler, right? Profile, and that's the name of a tool, allows us to trace the given program and look at this, where different threads are in the stack. This is different, for example, from perf, because tools like perf, they typically show you CPU usage. In this case, you will see where threads are getting stuck, where that is doing some CPU compute, where they are stuck waiting on Mutex, waiting on disk I/O, or wherever, which can be very helpful to understand, okay, what exactly is going on in the program, right? Why it's not running so fast. Another cool tool is understanding your I/O latency, right? Especially with modern storage in the cloud and so on and so forth. you often have to deal not with the averages, but with the outliers. And this tool pretty much allows us to understand the latency of your block device, right? In this case, it's kind of quite natural, right? We're not having a lot of outliers, but this is actually interesting, right? We can see for this block device, we had like one of the IO requests, which took what is it? I think that's microseconds, right? So that took 2 seconds, right, or something to complete, which is if you, for example, run in the database server and that happens to be something like your log flush request, then it's bad, right? It will have a very bad impact out there. Another, which is a very nice tool, which allows us to snoop the block device I/O, right? So if you ever wondered whether your I/O is sequential or if that's kind of random and what's not, you can rather easy to trace that with a tool, right? And then you can run some, some program easily, right, to analyze, plot, visualize your I/O pattern in more details. This is the block device. There are also tools to provide you the same information for file systems. And there are different tools for, this is for ext4, right? We can see how much file system main operations like read, write, fsync take, because again, for all kind of different storage reasons as well as internal kernel reasons, we may see file systems cause installs which can impact the operations, right, of our programs, right, in which maybe hard to troubleshoot otherwise, right, because you probably do not instrument every single I/O operation in your program. There is other the tool which is related to that, right, and if you do not want to trace everything or build a histogram, you can also use this tool to understand what kind of I/O operations do not meet your, let's call it, service level objective, right? So in this case, we can say, hey, what I/O operations took more than 10 milliseconds, right? And you can put obviously any number you want out there, and that tells, well, you know what, there have been these are requests which have taken so much time. Now, another interesting statistics, right? For me, I was always wondering, right, well, Linux has disk cache, right? But how efficient that is really, right? How do I really see, do I have a lot of hits, right? If I have more memory in the cache, is it really getting more hits or less? Well, with eBPF, you can do that, right? There is a Cachestat tool which shows me how many total requests have been reading from a cache, right? How many hits, misses, how many blocks has been dotted, right? And so on, right? And that really can help you to understand your cache performance. Another interesting thing. So if you look at your applications, which are CPU bound, right? One of the critical items in terms of where they would be responsive and perform well is when the application is ready to run, how long does it take kernel to find the CPU to actually schedule it on, right? Because if all the CPUs are busy, then it will have to wait until until other CPU becomes available, right, or preempted, and so on and so forth. This tool allows you to actually see that from a RunQueue delay profile, and you can see how long it takes before the program became ready to run to its scheduled, which is, I think, a very cool way to understand where you're having a CPU saturation, right? It's much better than just looking at your CPU usage averages, right? Okay. The next one. If you ever wondered for your program, right, which you have maybe not in the shell, but in some more complicated languages, what other tools and other stuff it executes, right? Well, there is this wonderful tool called Execsnoop, where you can look wherever for a whole system or for a specific program, what are different programs are being started, right? And that can help you to understand what the program does better, or if there are some problem, something fails, you can often figure that out, right, from this tool. The next one is open files. That, I think, is another also very helpful thing. I find that helpful when programs do not have a diagnostic error messages set very well. It says, oh, there is an IO error, or can't find a file. What file? Right? I mean, some Linux programs are getting the error messages which are as bad as the Windows errors. Right? So that allows you to deal with those programs, because you can understand what files the program's accessing, right? And from that you can often infer what could possibly go wrong and troubleshoot that, right? Besides files, you can also trace what the programs connect to in your system, right? This allows us help to trace the TCP connections, where outgoing TCP connections in your system, which again can be very helpful to understand how programs work and troubleshoot them as needed. This one I find a very cool one, right? So in many cases, what we see with database troubleshooting, right? For example, somebody complains, hey, the query is slow, but the query should not be slow, right? Because if you look at the logs at the, let's say, MySQL side, and it's all fast. Application sees it slow, right? Possibly that was communicated because of some network issues, right? In a lot of the modern networks, the latency would see is being quite good, but if you have some packet being dropped and retransmit happen, then that can introduce a huge delays before in that network communication. With this tool, you can actually see what exactly network retransmit happen, not just in aggregates, which you can get from NetStuff, but for specific connections. And then for those specific connections, I can also understand what program, right, application, if a user was involved out there. The next one, DNS lookup. That is a latency measurement, also sometimes not easy to figure out, and I think it's often misunderstood, not taken into account, but DNS lookup may be a huge performance impact for you connecting to the servers. Here are all the tools which are available in the version of BCC I used, and these tools are constantly being developed and extended. Moving on. For Ply, that is another tool which is wonderful to get some additional scripting if you want, besides running custom tools, right? For example, you can run this kind of simple probe which can say, hey, I am connecting to this kernel syscall, and give me the histogram of the return values, right? Relatively simple, gives us a beautiful chart. That is example of a Ply language, right? It uses a custom language, but if you've been doing the programming, that is a not too hard language to learn and understand. Okay, this is all the tools I showed you, which are based on kind of real-time troubleshooting analysis, which is wonderful. But what if you want to have some stats you want to analyze in the past? Yes, and there is a tool for that. Which the state of art, I believe, in this case, is Cloudflare's eBPF exporter, which is, as the name says, exporter for Prometheus. So you can get pretty much any data from eBPF in a Prometheus, which you can do wherever. You can plot it, you can use an alert manager, and do all the other good stuff. Now, here is a nice graph, in this case, which I took from a Cloudflare layers talk, which tells us what, while all of those things, they have the same average value, right, on both axes, these are completely different, different pictures. Right? If you haven't seen that image, I think that's kind of quite cool. Right? That is why we need to go beyond the averages, right, and even the mean values, and to really understand the histogram. So if you look eBPF Explorer, it uses BCC library, right, to get the data, and pretty much you can take the data from BCC programs and output that in a Prometheus format. One thing you have to be careful running Explorer in a production is the overhead, right? So if you put, for example, a very complex probe, and if you put that on a very common operations, right, which you run millions of times a second, you can have quite an overhead, right? As you can see, Cloudflare guys measure that can be way over 100%. So be careful what you run in production versus what you run in a test, or you only enable when a system is not healthy. So for eBPF Explorer, there are binaries available, right? You can get that and also provide the configuration information. You can plug it in a standard Prometheus, of course. I also show you how to integrate that with our open source monitoring tool called PMM, where you can pretty much add it as an external exporter. And what you can get in this case here, as example, is a IO latency histogram, just the same as I showed you early on in the presentation, which we can then go ahead and plot as a IO histogram over time, right, to visualize that in Grafana. And that can be used for us, for example, to help us to understand the outliers. Like, well, you know what, in this case we had, you know, some requests which have been taken more than 33 milliseconds, which is kind of slow for this SSD storage in this day and age. Okay, so what's coming in a BPF? What I'm very excited in BPF is Bpftrace, which is kind of in the style is very featureful Dtrace replacement. Right now it is it is not, you know, quite mature yet in terms of having packages available, but it is really getting there, and I would say that probably will be one of the very powerful eBPF tools in the next year or two. Here is for a reading list, right? As I prepared, I went through a lot of articles. I thought I will just leave it on the slide, and that's it. I think I have exactly a minute and a half for questions.
Please remain seated. Do we have any questions? Any questions?
Any questions? That was so unclear, no questions, right?
Yes, so the new tools appear, and there are like Dtrace, Ftrace, LTTNG, tons of that, 15.
Yes.
Which ones are likely to go away? Maybe you have compared them.
Yeah. Well, that is a good question, right? I mean, somebody before was talking saying, "Hey, Peter, why don't you talk about Dtrace and Linux, right?" And I say, "Well, Dtrace was wonderful, but it's kind of dead." Right? I mean, Dtrace is available, for example, in Oracle Linux, but how many of you here are running Oracle Linux? To prove a point, right? In this case, I believe what the eBPF at this point is the leading monitor tracing and instrumentation framework for Linux, for this kind of advanced instrumentation use case, which is there to stay, right? And I think that's where the future is. Make sense?
I have a question, which is a lot of these tools seem very, very useful to run in production systems because that's where you find the really weird problems that you cannot debug and reproduce anywhere. But the question is, I always see these things running as root and being advertised as unstable. So is there a better way for me to not be running things that are marked as unstable under root on my production system?
Oh, well, if you... well, there may be ways, right? But I mean, in the end, if you are inserting some, custom code into the kernel, right, you are doing something relatively dangerous. And as I mentioned, with the performance overhead at least, right, while eBPF is designed to avoid you crashing the kernel, you can make it run multiple times slower. Right, in this case. So in this case, that is advanced monitoring tools, right, which have to be done. Now, what I would imagine in this case, right, if you want your developers to do, then build the safe tools, right, and let them only to run those from sudo, right, or something for that particular use cases which you authorized. That's what I would think.
You have presented a couple of tools which are quite similar in the in the target that they can do with the Strace, for instance. So how do they compare to Strace, and do you think Strace should be rewritten in order to leverage eBPF capabilities?
The great question is how is that compares to Strace, right? The overhead. eBPF has orders of magnitude lower overhead than what Strace does.
So should we rewrite Strace to leverage eBPF?
Well, possibly, right? I'm not sure. Maybe there is actually work like to do that already, right? But in general, for the tools, right, the overhead I think is right now is a main difference with what you can do with Strace.
Any more questions?
Oh, you're getting your exercise here, right?
Yeah.
Up and down, up and down.
It's good for me.
Yeah, yeah, you can. You next?
No.
Okay.
So, all the way up.
Oh, you had the...
So we actually took histogram data of the audio coming off the microphone.
Oh, that's very cool.
Yeah, so my question is to the audience and to the speaker. Is anybody using this in production now? The exporter? No. Okay.
Yeah, Cloudflare has an exporter, right? I mean, there is, if you look at, there is a lot of people writing about using that in production, right? I know that Brandon Gregg uses that very actively at Netflix, right?
But he's using the tools individually at runtime, not the exporter.
Not exporter.
Yeah, I'm actually running the exporter in
production.
production.
Oh, you're asking about the exporter. That's that is a good.
So I would have raised my hand to my own question. So, but I was just wondering if anybody else.
Oh, you use exporter in production.
Yes, and it's not 23% slower. I've benchmarked it as well. It's pretty close.
Yeah,
it's worth trying.
Yeah, what I'm saying again is you have to be smart what probes you set up, right? You can set up a probe to fuck yourself up, right? As with many other stuff in Thinking's life.
Any other questions?
Okay. Well, thank you.
There was one question, maybe.